Hello everyone, this is Teo Samarjija, a computer engineer from Croatia. A thing I wanted to ask is, why is modern day AI so bad at writing assembly languages? I'm going to show you some anecdotal data to explain what I'm talking about. So, as many of you know, I'm developing a Picoblaze assembler and emulator written in JavaScript. About a year ago, I've written a solution to one of the classic puzzles in the computer science world called the n-queens puzzle in Picoblaze assembly language. The n-queens puzzle basically asks you to put n queens, usually 8, on an n times n chessboard so that no two queens are attacking each other. In chess, queens are attacking one another if they are in the same row, in the same column, or on the same diagonal. It is 336 lines of Picoblaze assembly code. It is solvable using the DFS algorithm, the depth first search algorithm. I implemented it using the stack. It is in higher level languages, it is usually implemented using the recursion, but in assembly language, it is way easier to use a stack than to use a recursion for implementing DFS. Last week, I ported it to x86 assembly compatible with flat assembler. I ran into a few problems, most importantly with dealing with reg banks. In Picoblaze assembly language, you have two reg banks, reg bank A and reg bank B, each containing 16 registers, S0 to SF, F being hexadecimal for 15. And you can switch between those two reg banks. I emulated those reg banks in x86 assembly by essentially storing the registers in variables and having separate groups of variables for each reg bank. That's quite an error-prone solution, and I made 2 errors when doing that by hand. Nevertheless, the program now works, as you can see on the presentation. So I decided that I wanted to port another one of my Picoblaze assembly programs to x86, namely my permutations algorithm written in Picoblaze assembly. My permutations algorithm in Picoblaze assembly is made of 2 parts. The first one is the bubble sort algorithm, as when we want to print all the permutations, the sorted array is the very first permutation. Then it uses a stack-based algorithm to generate all the other permutations. So I asked GitHub Copilot to, based on my n-queens puzzle program and its port to x86 assembly, make a port of my permutations algorithm to x86 assembly. Sounds like a simple and repetitive task for artificial intelligence, right? Well, not quite. After I have done that, I was amazed at how poorly it performed. It seems not to know such basics of how x86 processors work that even middle school students know, at least if they go to informatics competitions. For instance, it seems not to know that no instruction in x86 assembly has 2 memory references. It repeatedly outputs MOV instructions with 2 memory references, as well as some other similarly made up instructions. As well, it seems not to know the difference between a preprocessor constant and a variable in the memory, as it attempts to compare preprocessor constants using the CMP instruction. The reason why this would not work should be obvious even to a 7th grader, when we are taught about preprocessor constants and how they are different from variables in our IT classes. It will either segfault or not even assemble. Okay, then maybe it's bad at converting from one processor architecture to another, but at least AI should be good at converting from one assembler to another. Let's say I wanted to migrate from a flat assembler to a much more popular GNU assembler. I'll be honest with you, my knowledge of GNU assembler is minimal. However, I suppose you might have a misconception written in Kip Irvine's textbook that GNU assembler needs to use a completely different syntax than other assemblers. That's true in the distant past. For a very long time now, GNU assembler supports the Intel syntax similar to those used by other x86 assemblers. You just need to add to .intel underscore syntax space no prefix at the top of the file. And I informed the artificial intelligence about it. And I asked GitHub Copilot to port my nquins puzzle from flat assembler to GNU assembler. The result is basically useless. It almost always replaces MOVZX with MOV, which will either corrupt the memory or more likely it will not even assemble. And it does not understand what macros are. It thinks macros can be replaced with functions, which they in this case cannot. And it will also cause segfaults when dealing with preprocessor constants, instead of using conditional assembly, which GNU assembler supports, and it also supports macros, although with very different syntax than flat assembler. Here is the point. People often tell me that I should learn more about making create, read, update, delete applications and less about making assembly compilers in JavaScript. Why? Today you can get a basic CRUD app with a single AI prompt, but AI apparently really sucks at writing assembly. Shouldn't computer engineering students these days focus even more at the low-level stuff that the AI is not good at? Anyway, that's all for this video. Thank you for watching.